Alright guys, so welcome back to another video. Excuse me, let me get rid of this. So this is going to be a video response to some of the questions that I get when I upload these guys, especially like this guy here. That is nice. Anyway, let me turn it off, put the lid back on so I don't get killed. The question that I get asked the most, the absolute most, is, what is this for? And I think I've answered this a bunch of times, but I'm going to answer it now here in an official video, along with this one and all of my other motors. I'm going to set each one up and show you what I use it for. And the short answer is nothing. This is just an experiment. These are 3D. I'm trying to use 3D printing and pulse technology together. So this rim is 3D printed. This entire coil is 3D printed. This coil is. This rotor inside, the heads and the actual rotor housing itself is all 3D printed. The only thing that's not, obviously, is the coil, the magnets, the bearings, the shaft, and the circuit. And the circuit itself comes from another YouTuber called Sky Collection, who's like the goat of pulse motors on YouTube. So there is no real single purpose. I'm not trying to produce over unity. I'm not trying to do anything crazy. I'm just basically, it's having fun. It's seeing what I can do with 3D printing and pulse motor technology. I've had some people say basically it's a brushless DC motor, and it is, but we call it a pulse motor because this particular circuit sends pulses to the coil, turning it on and off really fast. I'm not sure. I think it's like, I don't know, 60 times a second or something, which then pushes the magnets, causing the rotor itself to rotate. So, yeah. And this particular coil, you have to give it a spin. You have to give it a decent spin. Almost all my pulse motors are not self-starters. Sometimes they are, but most of them are not. What I like to do is experiment around, powering this with different things like my Super Cat bank. Sorry about that. And then seeing how much power I can get out of it, just to see. If there's no real, I'm not trying to do anything crazy here. I'm just playing around, really. It's something that I've been doing for many, many years. There's a community on YouTube. It's not a very big community. It's actually pretty small. It used to be really big, like 17 years ago. There was a lot of this stuff on YouTube. There was a lot of people putting out HHO generators, hydrogen generators, pulse motors. Newman motor was really big back then because Joseph Newman was still around and he was still half naked doing videos showing his, I think it's called Big Bertha, his giant Newman motor. So this is a Newman motor, but his was set up a little differently. His was set up to run on a commutator, and there was a lot of sparking and a lot of high voltage, and he could run his off of a few 9-volt batteries, and it was huge. It was as big as this garage that I'm in. Well, not that big, but you know what I mean. It was really big. If you look it up on YouTube, Joseph Newman, I think it was called Big Bertha, or Big something, Big Eureka, I think it was called. And so he got us all excited about doing stuff like that in our own garage. I mean, to be able to make a motor like this in your garage, to me, was fun. Then John Bedini came along, or he actually came along at the same time, and he started with the Bedini motor and the Bedini circuit. And I've got a few of those circuits that I've made myself. Sky's made me some. K Energy's made me some. RD3DP is maybe some. These are other people that are in this community. Each one in the community has different goals. Mine is just to have fun, just to see the different types of motors that I can 3D print, or the different types of rotors, see what I can do with 3D printing the entire thing so that the whole thing is 3D printed. Because it used to be, before 3D printing came along, you had to do it with acrylic, or I've even done it with wood. I've made many rotors back in the day. If you go back to some of my earliest videos, you'll see them, they're made out of wood. But then I started watching a lot of Sky Collection videos, and he does superb work. He has all of his acrylic laser cut and all that stuff. I can't afford that. And back then I wasn't interested in doing it that crazy. So I would just cut the acrylic myself and build the rotors, and then 3D printing came. And that changed everything. So hold tight. Let me bring up another motor. Hold on. All right, so this one is called the solenoid motor. This is one of the best ones that I've ever done. And I did this in collaboration with another YouTuber called Spaceman Oz. He's a guy from Australia, and he was watching my channel for a long time. And he said, he said, listen, I've got this design. I want you to check it out, and maybe you can print it. I said, okay. He sent it over. The design looked really great, but we both saw that there were some issues with it. So over the course of several months, we redesigned it. I must have printed 1 million iterations of this guy. So this has a tube in it that goes through these 3 coils. These 2 are the run coil. This is the power coil. And inside this tube here that runs on these rollers, and everything here is 3D printed. And let me fire it up. It's pretty loud. It puts out a lot of power. Yeah, it's pretty loud, and there's not much we can do about it. I tried putting some soft material on the rollers, putting some rubber on the rollers, and I could probably do it, but it was just to see if we can get it done. And we did, and it came out really good. And so these are newly rolled coils right here. You can see how nice these are compared to this one. The idea was you could take the power that comes off of this and run it back into the system. I've tried that. It doesn't work. I think the closest thing I could do would be to take the power off of this, run it into a bridge rectifier. From there, run it into my super cap bank, which is this guy over here. Grab it. Oops. Hold on a second. Here's my super cap bank. It can get charged up to like 16 volts. There are 6 500 farad 2.7 volt capacitors in there. Run it into there, and then once it got up to 16, switch it over to running the running the circuit. It would last for a while, but eventually it would, because of entropy and all that stuff, it would eventually run out of juice. I actually get a lot out of this single coil. I was really surprised when I did measure it. Let me see if I can get it up there again. See what comes out of it. And let me see if I can get this guy in here and if it'll stay in here. Oh, I can't because maybe I could. Yeah, I think I could. No, these aren't in here properly. Anyway, again, it was just a challenge to see if I could build this guy, see if I can build it and get it going, because the design process for this took a long time, a lot of iterations. I have boxfuls of plastic that just didn't work, and to get this to balance just right, there are, I think, 25 3/4 by 5/8 barrel magnets in here, and there are spacers in between each magnet, and everything, like I said, is 3D printed. And the spacers, so there's a magnet, a plastic spacer, a magnet. I first used wooden spacers in here, but then I took it apart and I put 3D printed spacers in there, and each magnet is facing the opposite way. So north will be here, south will be here, south, north, north, south. So it's an alternating magnetic field. But yeah, I really like this guy. I'm never going to get rid of him. I'm not going to take it apart. Yeah, so let me get a different one. And again, no real purpose other than to see if I can do it. See if I can 3D print something like this, get it to work. I mean, this was, excuse me, this was kind of tricky to get this all together. And then I took, when I first got it together, all the coils looked like this one here. And that's because I was winding them with a coil machine and I wasn't taking my time. Then I started winding coils by hand, and you can see the difference. I mean, that's a nice looking coil. And I just never bothered doing the top one. But let me bring over another one, show you what's going on. Stay tuned. All right, so here's another one. This has got a combination of 3D printing and acrylic. Like I told you earlier, I did a lot of stuff in acrylic. This is a beast. Let me turn him off. And again, everything is 3D printed here. And each one of my coils and rotors has 4 bearings. This one actually has 8, two on each of these side mounts, and then 2 in the rotor itself. And again, 3D printing. Let me bring it around to the other side so you can see what it looks like. 3D printing technology. And I made this so that these caps hold these in, and there's a T inside there. Let me see if I have an extra one. I had an extra, I think I threw them all out. But anyway, I can unscrew this piece will slide out like that, and I can change it for longer ones, and I've done that. This is one of my bigger coils that I've hand wound. Looks really nice. Again, 3D printed. So yeah, this is a nice one. It's pretty big, pretty unruly. Nicely balanced though. And again, I've got a bearing here, a bearing here, a bearing here, a bearing here. Yeah. So I can hold this and it will spin, or I can let it go and it will still spin. And I do that because I get more spin out of it that way than just having it fixed to the shaft. And then I can also easily change out different rotors. Like I've got this big beast right here. I can't take it too close to that and bring it over here. This beast right here, these are, and all of the magnets that I use are N52s. This is a beast right here. But this is set up to be a stationary rotor inside of a shaft. So it goes on, you know, it gets forced on actually. And I thought about putting rotors on opposite ends here. Let me get this set up over here. Putting rotors on opposite ends of these and putting coils down here and collecting the power that comes off of that. But I stick to doing stuff like this. And again, this was all 3D printed. This was printed on, I think this was printed, this was one of the first things I printed on my new A1, my Bamboo A1 Labs. And I usually print these rotors with PLA, but lately I've been using Pet G, because Pet G is a little bit stronger. PLA is plenty strong, but I've had a couple of rotors explode on me, and it was kind of gnarly. Thank God I never stand right in the direction of the rotor, and they usually go flying up this way, or they go because it's usually spinning like this, and when it busts, it usually goes flying off to the back. Sometimes it'll come flying this way, but I'm not in the way. I think I've only had 2 explode on me. One because, and both times it was my fault. But again, no real purpose. Not trying to, produce over unity. I'm just playing around here. And that's that one. Let me show you another one. Stay tuned. All right, so this was one of the very first ones I ever 3D printed. It was on my Ender 3 Pro, I think. Yeah, this was the first 3D printer I ever had. Inside here are 2-inch disc magnets. I have some around here, but you guys can know what those are. And I learned a lot of lessons from this. This is all glued together. And I use this special type of glue right here. I've got some of that PLA goop on order, but man, that's expensive. But I use this acrylic fast set number 16, and it works really, really well. Hold on. And this is a fixed rotor, or a fixed shaft, so that's glued in there too. And the lessons I learned from this was, if I'm gluing stuff in, I can't make changes. So now I don't glue anything. I make it all press fit, or I screw it together. But this would go in that same frame that I showed before. And it's pretty ruly too. I don't know how many are here. 1, 2, 3, 4, 5, 6. Yeah, 8 of them are here. Yeah, 8 disc magnets. All my rotors are set up the same. North, south, all alternating poles. Yeah. So I wasn't going to put this in the frame and show you, because it's basically the same thing as the other ones. But again, no purpose. It's just to see if I can do it. This was a long 3D print. Inside here, I've got supports that are glued in there. I don't know if you can see that. Probably not. There are some supports in there. Yeah, you can't see it. Anyway, let me show you another one. Stay tuned. So for a while there, I was doing a lot of stuff with VCR bearings. VCR bearings are some of the best bearings to do this with. I've even tried to do it with 3D printed bearings, but there's no real way to do it with that. But this guy runs off of one coil, and it, puts out some pretty good power. And so I've done a lot of experiments with VCR bearings. And I'm probably going to do more with it, because I just looked at a couple of Sky Collections videos. I do a lot of copying and then changing it a little bit. Like I'll watch one of Sky's videos, and he'll have something like this, and I'll change it up a little bit. And again, it's all about the engineering and the 3D printing. I don't know if you can see. This is all screwed together. Nothing's glued. I got little orange spacers in there because I didn't measure correctly, which is something I often do. But yeah, VCR bearings are really good if you want to have a bearing that spins freely for a long period of time. All right, stay tuned. All right, so this guy is one of the nicest test stands that I have. I had one like this before, but it wasn't set up really well. This one, I can put in floating rotors that are set up in a maglev type situation. I can also run a rotor up here with 2 coils, a rotor down here, but let me get this guy going. So right now it's running off of 2 bifilar coils. I'm only running it on one of the, I got to turn it down because this guy gets a lot of speed. and it puts out a lot of power too. Anyway, yeah, you can see this guy floats, and again, I can hold this and it will spin, or it will spin on all 4 bearings. There's one up here, one down the bottom, and 2 inside the coil. Right now I have it running on a power, and all of my pulse motors, all of them, every single one I've ever made, runs off a power supply or a super cap bank. None of them power themselves. That's yeah, I'm not even gonna go there. None of them power themselves. They all run off of this power supply in the back here. It's in all my videos. You can see it clearly in all of them. So this guy runs really well off the 2. And this coil was made by Sky Collection, and I copied it. I made one of my own. I didn't wind it very nicely because it wasn't meant to be a scene coil. And when I do run it like this, and I run a bridge rectifier off of the other side of the coil, I get really high voltages. I don't get a lot of amps, but I get really high voltages, up in the hundreds of volts. But because there's no amps, it's powerful enough to run another pulse motor. That's what I'll do sometimes to see if, you know, these have any real powers. I'll see if I can run another pulse motor with it. And I can run that solenoid motor off of this circuit right here, running off of this one here. Or actually, I'm sorry, I can run the solenoid motor off of the other side of that coil into the bridge rectifier, into the power of another circuit running that solenoid motor, the one I showed you that had the ring that goes like this. Yeah, this guy's really nice because, like I said, it floats. So there's not a lot of friction. There's obviously friction on the side of the bearing, but I can grab this and it will run off the center bearing. This particular rotor I have in there is a little tight. Let me shut it down. Yeah, it's a little tight, so I can stop it faster just by holding this. But most of the time, I can go like this and it will just spin freely, but it's a little tight in there. And again, 3D printed. All this was 3D printed. The coil housing, the rotor itself was 3D printed. I've got a mouse or something in my garage because I can hear him in the walls. Here, listen. Come on. Sorry. Yeah, he's behind there somewhere. Or he's in the walls, or... That's all right. I'm moving out of this place anyway. Getting a nice big garage, big 2-car garage for a shop. I can't use the whole thing, but it'll be a lot better than this. This is a 1-car garage, and man, after 20 years of filling it up with woodworking stuff and metal stuff and electronic stuff, I am so crowded I can barely even breathe in here. Anyway, there he goes again. Let's see if I can spook him a little bit. Hey! Get out of here. Anyway, yeah, I got a mouse in the wall. I heard him the other day. He was in the wall behind me. It's either a mouse or a raccoon or something. Anyway, floating bearing, all 3D printed, no purpose, except to have fun and to see if I can do it. It's the same thing when, you know, some guy climbs a mountain, right? It takes him a week to get up there, and he gets up to the top and turns around and goes back down, and they say, "Why did you do that?" And he said, "Because I wanted to, because it was there. It was simply something to do." Anyway, stay tuned. I got one more to show you. All right, so this was the hardest one I ever did. This was an idea that I saw about 17 years ago. I saw it on YouTube, and a guy had this setup, but it was much bigger. It was huge. It was like maybe 2.5, 3 feet by 3 feet by about 4 feet. And it was wooden, and it was wild. And he had commutators that run these magnets. So there's magnets inside this outer ring right here, and it runs the coils. And in theory, this shouldn't work, but because of something called anti-syncing, it does work. So when I turn this way, it should either turn this one up or this one down. It can't do both, right? So if I turn it like this, that's going in the opposite way it should go. That's anti-syncing. So basically, it's syncing with this one, and the rest of these are all anti-syncing. But it works, and it is crazy. When I first showed this on TikTok, people lost their freaking minds. I was being accused of everything but from witchcraft to all kinds of crazy nonsense. No, I wasn't being accused of witchcraft, but people were accusing me of all kinds of stuff. And I'm like, dude, it's just a 3D printed figure 8 rotor. And it took me a while to get the spacing just right. Because again, it shouldn't work, but it does work. Sometimes I got to give them both a start, but once I get it going, it gets them all going. And the plan was to put magnets around the outside of these and coils on the outside of this, so that I would have 3 outputs to 1 input. But I decided not to. It was too much. It took me forever to do this. These took forever to print. These all printed in one piece. These are separate, and I had a lot of good suggestions. Some guys said I should separate these and let these spin freely, which makes a lot of sense, because then if I spin one this way, it'll spin that one that way and that one that way. But I'd still have to have one that was countersinking. But I wanted to do it the way the guy in the original video had it set up. So let me set this up and get it going so I can show you that it actually does work. Stay tuned. All right, so I got it going. I've got the circuit hanging way down there because it's really hard to set this up. But it's working. Running off of these 2 coils off of this power supply. I'm going to turn it off because it's really noisy. And it's killing my circuit over here. And one of the things came out anyway. But anyway, it does work. And again, I just did it because I saw this, like I said, about 17 years ago on a YouTube channel. And for the life of me, I cannot remember the name of it. I wish I had saved the video, but I didn't. Yeah, it's a beast. It's not really, I mean, it doesn't work really well. I've got to, yeah. But it works even though it shouldn't work. And people lost their minds. Like I said, they thought they thought I wasn't saying that it was hooked to a power supply, that it was just running like this with no power, and I never said that, not once. I was like, oh, come on, guys. Anyway, that is why I do this. I do it because it's fun. I do it as a challenge to see if I can 3D print these motors to make them work, these pulse motors. That's pretty strong too, that magnet interaction. Oh yeah, and when I first did this guy, I had it set up for a traction, I think, or repulsion, and then I changed it to attraction, and someone said I should do it every other, north south, and that was the correct way to do it. Whoop. Anyway, that's why I do it, guys. I appreciate you watching. There's no secret motive to any of the stuff that I do. It's just to have a good time, to have fun, to see if I can do it. Oh, that's what's going on here. I gotta push this guy in here. Oh man, it almost came out. Oh, that's no good. Anyway, yeah, that's, I gotta fix that before I put it back in storage. That's why I do this stuff. All right. So I hope that answered your question. Thanks for watching. I'll see you around. Ciao.